Hello friends, today I want to take a look at Packet Tracer 521, configure VTP and DTP. You can see we have three switches here and we want to configure dynamic trunking protocol or DTP and also VLAN trunking protocol or VTP and verify that it works and how it works for us. But first, we should take a look at what is this description and what is the function of these two protocol. VTP is a Cisco proprietary protocol. Is used to exchange VLAN information. VTP allows a network administration to automate the management of VLANs. Consider you have 100 switch in topology, for example, here, and you cannot go to and enter to all of the 100 switch one by one and create VLAN and name VLAN and something like that and configuration. You can manage VLAN configuration from one switch only as a server, and this is VTP mode that help us to synchronize VLAN information inside the switches in the same VLAN domain, for example. And about and regarding DTP also, DTP is a trunking protocol that proprietary, it's a difficult word, to switch, and which is used to automatically negotiate trunks between Cisco switches. It's a secure protocol um, because, for example, I mean, if you set, for example, this interface for um, no negotiate or for the dynamic desirable, and in this function, uh, we say to this interface, you should look at the other side, or maybe uh, you don't care to other side. What is the other side's trunking or access mode, and something like that. And it's like a negotiation. And trunk negotiation between network devices is managed by a dynamic trunking protocol. And we order to our interface about you should look at the other side or you cannot uh, take a look at the other side and something like that, whatever. First, we should configure and verify DTP. First, we should verify VLAN configuration. We can go to switch 1, switch 2, and switch 3, and right here show VLAN brief, and you can see we have two VLAN here that we have already created, 99 and 999, and rest of them such as 100, 1000, 2, 3, 4, 5, it's by default, you can see in all of the switches. It's by default. And it's same also process for switch 2, only we want to check, and all of the ports that you can see here assigned to switch 1, default VLAN 1 by default. Yes, and also here, all of the ports and interface assigned to VLAN 1, and also we have VLAN 99 and 999 here. Yes, and also here. Yes, and also here. Yes. And what VLAN are configured on the switches? 199 and 99. Yes, 999 and 99. Yes, that's correct. And we should go to step 2, and in step 2 we can configure trunks on S1, S2, and S3. We can go to switch 1 here and configure terminal mode. We want to manage trunk links between Cisco switches by DTP, Dynamic Trunking Protocol. And in this step, you will change the trunking mode to dynamic desirable for the link between switch 1 and switch 2. If you write here, for example, configure terminal and interface G01 that connected to switch 2 and say switch port mode trunking mode yes trunk dynamic desirable yes, and it will be up. But what is the process? If you write here dynamic desirable and you set it here, this interface look at the other side. If, for example, it will be trunk and also it will be trunk. If it's, for example, access, it will be also access. Yes, and it's like it's due to security and due to some configuration. And also interface G02 for the link between switch 1 and switch 3, link will be set as trunking mode, switch port mode trunk, yes, and it's trunk. There is no need to negotiate, it means, but in G01 it was a negotiation between G01 in the switch 1 and G01 in the switch 2. And also we should go to switch 3 here, configure terminal and interface G02 and switch port mode trunk. It means we don't need to have any negotiation here. And if you write here show interface trunk, you can see G02 is a trunking mode and native VLAN in number 1. What is native VLAN for these trunks currently? This is number 1. This is not correct, but it's reality. But what about here? We can write here and come back to privilege mode and show interface trunk, and you can see also a status for G01 and G02 is trunking, but you can see mode is desirable. Mode is desirable, and this is special for Cisco, and it means it look at the other side and it will be trunking mode, and on is a standard protocol, and also the status is trunk. Native VLAN for both of them is 1, is not true, because it should be, I think, 999, I think, but we should find out. Yes, it's true here. And also VLAN allow on trunk, you can see here, and VLAN allow and active in management domain and something like that. And it's the same process also for switch 2. Configure VLAN 999 as a native VLAN for the trunk links on switch 1. If you have the trunking mode between, for example, 2 switch, it's also important. You should set native VLAN, and native VLAN should be same for all of the switches in the topology is important. You cannot set, for example, VLAN 1 for switch 1 as native, or for example, VLAN 100 in switch 2 as native VLAN. We can go here and configure terminal and interface G0 range G0 1 to 1 to 2, and right here switch port trunk native VLAN 999. Yes. And what message did you receive on switch 1? This is the message. First blocking G01, and after that, this is mismatch. Discover on G02 with S3 gigabit G02. Yes, this is a, I mean, this is the message that we have received here. But to correct native VLAN mismatch, because in the other side, native VLAN is number 1 for switch 3 and switch 2, and it's you can receive any mismatch here, and it is the normal. And on switch 2, switch 3, you should configure also VLAN 999 as a native VLAN, and this is solution for this mismatch. Yes, as also I mentioned, you should set same native VLAN for all of the switches in the topology. You should go here and configure terminal, and same also you can see same mismatch message here. Configure terminal and interface G01 and switch port trunk native VLAN 999, and I want to copy this command and right here also configure this is true, interface G02, and you can set also this native VLAN, but there is no mismatch message more here. You cannot see, and we have also removed this mismatch message by this configuration automatically. And verify trunking is successfully configured on all of the switches. For verifying, you should use show command. You should be able ping on one switch from another switch in the topology using the IP address configure on SVI. For example, here you can write show interface VLAN to verify and investigate trunk. Investigate what is your native VLAN here. This you can see this is 999, and same process also to show interface trunk, and same process, and also same process for switch 1. And we can also ping, for example, switch 2 can ping switch 3 or not. Yes, and also can ping switch 1. My bad. Yes, and also it can ping. It's successful. Yes, and now we should continue with configure and verify VTP. S1 will be configured as the VTP server. DTP is finished here in part 1, and we should continue in part 2 and focus on VTP. And we want to manage all of the switches here in the topology, and S1 will be configured as the VTP server. Is important. Is like a leadership, and S1 is a leader of our domain here, and S2 and S3 S2 will be configured as the VTP client. All switches will be configured to be uh, in the VTP domain CCNA and use the VTP passport Cisco. And it's important. We should set any domain here, and for all of the switches, for example, and say to switches, you are member of this domain, for example, and we should set one switch for server. It's like a leader, and all other switches should be set on client. And in this process, you should go to switch one here and VTP mode server here. You can also get any confirmation. And what is domain name? Domain name should be CCNA, and also VTP password Cisco. Use show VTP status command to the switches to confirm that the VTP mode and domain are configured correctly. To verify the password, use the show VTP password here or switch one. We can write here to show VTP status. I've used do here because I want to use show VTP status here in in global mode, and you can see some information here. This is password. This is this is VTP version 1, and maximum 255 it can support, and also number of existing VLAN is 7 because it's such as 199, 999, 1000, 1, 2, 3, 1000, 2, 3, 4, 5. Yes, it's 7. And mode is server because we have set it on server. And what is the domain name? This is CCNA. And something is disabled here because we didn't activate them. Yes, it's about switch 1. And what about switch 2 and switch 3? Switch 2 and switch 3 also we should configure in domain, and also we say VTP mode they are client, and S2 and S3 should refer to switch 1 and get VLAN configuration and some information from switch 1, and also VTP domain CCNA, and also VTP password Cisco. Do show password, do show VTP password. As you can see, VTP password is Cisco, only we want to verify. And it's same process for switch 3, configure terminal, and we can copy this command VTP mode is client, VTP domain is CCNA, and VTP password is Cisco. And also you can write and get some information here to show VTP status, and you can see, for example, VTP version 1 and mode is client and VTP domain is CCNA. And but on S3 we want to set VTP mode to transparent, and I will describe for you what is the difference between them, and you can write, you can um, change it here to transparent, yes, and again you can see VTP operating mode is transparent. We have three forms for VTP mode: VTP client, VTP server, and VTP transparent. VTP server is a switch using this mode, cannot change its VLAN configuration, and all of the switches refer to server one, VTP server. And about VTP client, VTP clients switch using this mode can create and delete VLANs. Oh, excuse me. It should be, yes. I should write anything here and start again. What is the description? Yes. Start again. What is VTP server? VTP server is a server and is a VTP that this switch can create and delete VLANs, as we have also mentioned. And VTP client is a switch that using this mode cannot change its VLAN configuration, only can refer to server. But what about transparent? Transparent is a switch that um, that this switch cannot share its VLAN database, and but it forwards receive VTP advertisement only forward to other switches, and uh, doesn't share its VLAN database, and it's a differences between uh, client and server and transparent. Now on switch 1, as a server, we can create VLAN. We can go to switch 1 here and create VLAN 10. Yes. And name should be red, and VLAN 20 name should be blue, and VLAN 30 name should be yellow. We have also created them, verified the addition of the new VLANs, enter show VLAN brief to add the privileged exec mode, which VLANs are configured on S1. Show VLAN brief, and you can see we have added 10, 20, and 30 VLAN to switch 1, and also confirm configuration changes using the show VTP status command on S1 and S2 to confirm that the VTP mode and domain are configured correctly. Output for switch 2 is shown here. same. Show VTP status. Yes. And you can see number of existing VLAN changed to 10. And what about here and show VLAN brief? And you can see without configuring 10, 20, and 30 directly in switch 2 can get information and VLAN information from switch 1. And also it's same here. Oh, it's not same here because it is transparent. They cannot save, and transparent cannot save any VLAN information here, but can send to other switches. If, for example, you can see switch 4, for example, here, and you have any switch here, forward to switch 4, and switch 4 can get other information and VLAN information from switch 1, but um, switch 3 by itself cannot set it in the database and in VLAN database and VLAN table here, as you can see. And this is the um, um, description of transparent here. How many VLANs are configured on switch 2? It was 10. Does switch 2 have the same VLAN as S1? Yes, because switch 2 and because switch 1 is the VTP server and switch 2 is the client server in the CCNA domain is important, and S2 has received VLAN information from server and from switch 1. And for S3, use show VTP status, show VTP status. Yes, you can see number of existing VLANs is 10, is, excuse me, 7. What is the configuration revision number? Yes, it's 0 here. And explain your answer. Um, there are 7 VLANs here on switch 3 and configuration is 0. Yes, because S3 is in transparent mode and VLAN configuration have not been changed since switch startup. Change VTP mode to client on S3. Yes, it's client. And use show commands to verify the changes to VTP mode. How many VLANs exist on switch 3 now? It changed to 10 because it's in client mode under CCNA domain, and configuration revision is 6. Yes. And assign VLANs to ports, and in this last step, we should assign some interfaces to VLAN, for example, VLAN 10, 20, and 30. We can go to switch 1, only you should configure on switch 1 as a server, and switch 2 and switch 3 can copy this the database and this information from switch 1. And here and use the switch port mode access command to set access mode for the access links. Use the switch port access VLAN ID command to assign a VLAN to an access port. For switch 2, assign VLANs to ports on switch 2 using assignment from the table above. It's on switch 2. You should go to configure terminal mode, and here interface range facet net 01 to 8 and switch port mode access. Yes. And also switch port access VLAN 10 because it's important. You should set only one VLAN for access mode because you have 4 VLANs here, 10, 20, 30, 99, and 999, and you should set only one VLAN in this interface because it's access mode. And also interface 9 to 16, and VLAN should be 20 based here. You can see switch 1, switch 2, switch 2 for VLAN 20, and switch 2 for VLAN 30 should be facet at 0, 17 to 24. And we can write here VTRN should be 17 to 24, and it should be access mode, and it should be VLAN 30 assigned to VLAN 30. And also same process for switch 3. You can go also to switch 3 here, and interface range facet Ethernet is same. For example, for VLAN 10 is 1 to 8, and switch port mode access, and switch port access VLAN 10, and also 9 to 16, and 17 to 24, and any additional notice here, you didn't need to um, write any or set any native VLAN here because it's access mode. Only under trunking interface you should set native VLAN. It's not. And verify end-to-end connectivity from PC0 can ping PC5. This is PC5 and this is IP address. And from PC0 can ping PC5 and PC4 because PC4 is under VLAN 20 and PC1 also you can see here under VLAN 20 and assigned to VLAN 20, and in this situation only PCs that assigned to VLAN 20 can ping each other. PCs assigned to VLAN 10, I mean PC0 and PC5 can ping each other, and PC2 can ping PC3 because they are in the same, you can see they are in the same subnets and they are in the same VLAN here, 32 and 31 can ping also each other. And as you know, to configure other thing about, for example, VLAN 20 can ping VLAN 30 and something like that, we need to have other configuration and trunking mode and something like um, I should use access list and I should use some configuration, more configuration. Yes. Thank you for watching and please subscribe me and support me and leave any comment for me. Have a nice day.